The skier reaches point C with a speed of 8.2 meters per second. She stops after a distance of 24 meters at point D. Right, so let's go back and look at this. It's like, whoa. Okay, so 24 meters, C to D, it's level. Notice that the ground is level. They're going 8.2 meters per second, right? Okay, so determine the coefficient of dynamic friction between the base of the skis and the snow. Assume that the frictional force is constant and that air resistance can be neglected. So it's just the force of friction slowing them down, right? Okay, so I think the first step is to Suvat this, right? Right, and find this acceleration, right? So our initial velocity is 8.2, our final is 0, our displacement is 24. I think you'll use no t and find the acceleration, yeah? So find that first, okay? And let's see, hold on. I get this like 1.4 meters per second squared, right? Okay, so find the acceleration, right? Then our next step is that what they're saying is the force of friction is what slows them down. So that's going to be the net force. So mu times m times g, which is what the force of friction turns into, right, is equal to ma. Notice that the mass doesn't even matter, right? Okay, so plug that acceleration in there, right? Plug 9.81 in there, solve for mu. And I get like something like 0.14 or something like that, which is, that's typical, right? Okay, so that's how to do that. Now, keep in mind that when you get to the final, I'm going to change this question, okay? All I'm going to do, instead of this weird, like, find the coefficient of friction, I'm going to say, what is the net force slowing down the skier, right? And that's easy. The net force will just be find the acceleration, and then F equals ma, right? Okay, so to answer the question on the final, you're just simply going to find the acceleration and multiply that by the mass, and that'll give you the acceleration. I'm sorry, that'll give you the net force. Sorry.